Hey engineers, and welcome to 3.1.5, part 2, which is functions. Today we're going to talk about functions and what a function is inside of a program and how it can help you, what it's good for. And it's maybe helpful to think about what a function is in math class. A function in math class, let me just do a Google image search for math function. My C key is not working these days. It's really annoying. What a math function is it takes one number and it maps it to another number. Maybe you're used to seeing functions like y equals like 4x plus 3. You know, that's a linear function. Or you've got like y equals 6x squared minus 2x plus 6. That's a quadratic function. But in reality, we use the word function all the time. Like, what is it actually? What a function is it takes something in and then you get something out. It changes it somehow, and there's all sorts of things that you can put in there, to do that. In coding, what a function is we're going to leave the main program, go elsewhere and do a job, and then come back to the main program. And let me show you what I mean by that. I'm going to write a function for you guys. So I'm opening up my template and I'm picking that project lead the way. I forget what it's called to name everything. So here I'm declaring my function. And I'm calling it claw down up. So I'm going to be pretending like it's a claw machine that you play when you're a kid. So I named it claw down up because those claws go down and they come back up. So here's where I call my function. If I push the limit switch, then I want to go do something else. Here's what we call the function definition. Like you're going to make up a new function, but then here's where it's actually going to do. Like I'm going to code this thing. It's pretty menial coding. I'm starting a motor until it spins twice, and then it's going to stop and go the other way, spinning twice, and then stops the motor. Okay, friends, here's my code I just popped into existence, and here's how it works. Here's what's going on. Here's our task main function. Number one, I'm going to have like almost another function. So this task, I keep referring to this as the task main function because it itself is the main body of this thing. So I'm going to loop this forever. And if you ever want to get outside of this, the only way to do that is to call up another function. So here I'm pretending, do you remember in the other, we talked about the claw? Those games that you move the claw forward, backward, left, right, and then you push the button and it goes down and goes up. So if you want to do something many, many times over, like the claw going up and down, if you want to always be performing something, rather than having to code this stuff, can copy and pasting it. If it's like in music class where you have like a section of music that you always play, you just call that up and then you go back to the original. I think that's like DCL Coda and things like that. That's what I'm doing right here. So while 1 equals 1, when I push the bump switch is what moves the motor. And then when I'm ready to drop the claw, I made my function call. It's called claw down up. So I can name it whatever I want. You can't use the reserved words. But now when I get here, I'm going to jump out of my task main. I'm going to jump out of this and I'm going to jump down here to this function. Now my function has to, number one, it has to have a declaration. I'm saying up front that I'm going to be using a function. I have to somewhere, you don't have to, but if you want to call that function, here's how you call it. You'll notice these first two parts have semicolons to them. And then somewhere you have to define your function. What is this function actually doing? So here, and you'll notice that it's almost similar to the task main. Like I have task main, left parenthesis, right parenthesis. Now I've got claw down up, left parenthesis, right parenthesis. So here is me creating a function so that whenever the limit switch is pushed, I'm going to jump out of, run this stuff, and then come back. Here's a pro tip. If you're ever going to use a motor to do something, your motors, the less battery power that they have, the slower they're going to spin. So I don't like JV coders will just run motors for time. They'll say run it down for 5 seconds, run it up for 5 seconds. But as your battery degrades, 5 seconds isn't going to go as far. It's better to tie your motor to rotations. So it's like no matter how slow or fast it's going to go a certain number of spins. So I used this, keep it going, I just want to spin it twice. So 2 rotations, it's going to go down the same distance every single time. And that's a better way to make motors go certain distances. Or you can use your sonar or something like that to do it. Let's go back and look at this kind of more formally. Functions. You have to have a function header, which we said you're declaring it and you define it and then you call it. Here's another one that they made. This is really lame. It's like, here's your task main. So you're going to loop this continually and you're always going to be jumping out to do this. So it's like a really basic example of a function call, and there's no I didn't like it as an example, so that's why I kind of wrote my own. So here's your declaration up front. It's almost like a global variable. You define your function at the end after. So you can have multiple functions. You don't just to have one function. You can have so many functions depending upon what you want to do, and you just call them when you need to. It's really cool. It's like having a custom tool. Call it when you need it instead of having to code it all. It makes your code way less jumbled, and you can do some pretty powerful things. And then you call it. They call this the function call, where you actually inside of your code make that call to the function. All right, friends. That's everything for today. I hope that you learned a little bit about functions, and you can maybe keep these in mind as you're making some of these complicated programs.